All right, so we have reached the end of the course. And again, what we explored, let's just kind of, very quickly go through all of that. So we saw as to how to write a device driver, right? And we focused on using proc as, the file system that we interact with, right? Then as part of writing this, we understood the compilation process, how the module gets compiled. Then we saw how to load the module, unload the module, right? And then we looked at other utilities that help with debug and analysis. We looked at all of that. Then we looked at how to go about actually implementing. Well, actually, let's put it this way. We looked at the basic components of the driver, right? The init, the exit, and then after all of this, we looked at system calls, and specifically those that relate to file operations. And the file in our case, or the file system in our case, was again proc. I just have to reiterate, this is not a real file system. There is no block of memory associated with this on the disk. It's virtual. And then we looked at how to create proc entry, right? And how to interact with it. And as part of that interaction, we looked at the read system call, right? And then towards the end, we explored interaction of user and kernel space. So this is kind of what we looked at, and trust me, this is what every kernel driver has. Boils down to this pretty much. And let's talk about what we have not taken a look at, and what you can kind of try and explore on your own, or follow along in the next course that we plan on releasing on the Linux device drivers. So what we have not seen is the character device driver, and how to actually create like a node within slash dev. We haven't seen at how to go about implementing other system calls, right? Open, close, read, write, those kind of things. And most importantly, we haven't looked into, so if this was our Linux kernel, we haven't looked into how to actually go about, controlling or interacting with an hardware. Let's say an LED, for example, or a switch. How can we have the Linux kernel module interact and handle actual hardware that we haven't seen yet? Then we haven't seen kind of uh, modules that are preloaded in the kernel image. What does this mean? So this means that as your system, like the Linux kernel boots up, your driver should be already part of it. That exploration we haven't done. We haven't also not looked at something called um, device tree, right? And the link of device tree to the module, we haven't looked at that. And there are, of course, many more things, but knowing this in addition to what you already know can actually get you to a comfortable start on a device driver's team, where you wouldn't be asking basic questions to the senior team members. Rather, you will be ready to fire and ready to contribute, to the point that you can actually deal with hardware. With what you have studied in this free course, you'll of course be able to kind of absorb more information from any of the seniors on your team, But with the next version or the follow-up course on the Linux device drivers, you'll be able to go down and control the hardware, right? And so with this, then I hope that you enjoyed this free course. And if you like this course, do leave us a feedback, do rate the course. And I request you to kind of spread it around in your peer group also. And with this, I'll see you in the next one. Bye bye.